Unit 7, the coordinate plane, Lesson 4, graphing functions. We have two vocabulary words, a linear function and a nonlinear function. A linear function forms a line when graphed on a coordinate plane, and the nonlinear function does not form a line when you graphed on a coordinate plane. So a linear function is where you're going to graph points, and if they connect and make a line, it's called linear. Or if you connect them and they don't make a line, then it's nonlinear. You can use your smart device, scan the QR code to watch the virtual nerd video for how to graph a function. We're going to start out very easy, graphing a function from a table. This is where you're going to use the x and y values from the table to graph the x and y coordinates. And you're going to connect your points. So you're going to look at your input, output. Remember, your input's your x and your output's your y. So you're going to locate these points. Input was 1, output was 3. X was 1, y was 3. So my coordinate here is 1, 3. So I'm going to go over 1 and up 3. My coordinates for the next one would be 2 and 6, 3 and 9, and so forth. And notice they go along. When we connect those points, they make a line, and this is called a linear function. So here we are given a table, data table, and we are determined to determine whether the relationship is linear or not, which means we need to go and graph these values, these coordinates, and if they connect to make a line, then it's called linear, so we say yes, and if they do not, then we say no. Remember, input is x, output is y. So my coordinates here are 1, 5, which means I'm going to go over 1, up 5. I'm going to go over 2, up 10, because they're all positive. Over 3, up 15. Over 4, up 20. Over 5, right here, 25. And if I was to connect those dots, and I'm not making the best of the line, but they are a straight line, so they are linear. So I'm going to write yes. If I look here at 2, tells me to go over 10, up 20, so 10 to 20. 20 to 40, over 20, up 40. Over 30, up 60. Over 40, up 70. Over 50, up 100. And if I was to connect those dots, they do not form a straight line. And so I would say, no, this is not linear. I would like you to go ahead, pause the video, take a minute, plot those coordinates. Remember, input is your x value, x coordinate, and your output is your y coordinate. Connect those dots, and if they form a line, it is linear, and if they do not, it's nonlinear. Now, graphing a function, okay, make a table of the values for the function table. Choose lesser values for the independent variables, x input, and plug the independent variables, which is your input, or x, into the rule, and solve for the dependent variables, your output, your y, or what we've been calling f of x. And then we're going to graph. So here they made a table for some points of the function y, or that would be f of x, equals x plus 3. And it says to choose lesser values. So here they chose -2, -1, 0, 1, and 2 for our x. And then what they did is they plugged in x here and added 3. So if you notice, here's where they did the plug-in, and then they added and got their y values right here. Then they went over here and they plugged in those coordinates. So like this would be a -2, 1 coordinate. This would be a -1, 2, and so forth. We're going to practice that now. So here they've asked us to complete the table and graph each function. They gave us values to use for x. So here is our x, which is our input. Okay. And then here's our y, which is our output, or what we know as f of x. Okay. And notice they use that here. So they tell us for x use -2, negative 1, 0, 1, and 2. We're going to use this rule, x minus 1. So here's my x, negative 2. So I'm going to plug that in, and I'm going to say negative 2 minus 1 equals a negative 3. So that's my y right here. For the next one, I'm going to plug in negative 1 minus 1, and that gives me a negative 2. I'm going to plug in 0 minus 1, which gives me negative 1. I'm going to plug in 1 minus 1, which gives me 0. And I'm going to plug in 2 minus 1, which gives me 1. So now I have my coordinates. So my coordinates are negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, and 2, 1. And I'm going to go and plug those in here. So I have my first coordinate, negative 2, negative 3, negative 1, negative 2, 0, and then I go down negative 1, so I just stay on the x and go down on the y. 1, 0, so don't go anywhere for the y. 2, 1. And then you connect those dots. That's a linear function because it made a line. Let's try that for number 5 here. So again, here's our x, here's our y, or remember we can call it our f of x, function of x. Again, we're using these values, negative 2, negative 1, 0, 1, and 2. I'm going to plug in wherever x is in my function here, my rule. I'm going to plug in these values. So my first one's going to be 3 times negative 2, and that's going to give us a negative 6. Then I'm going to take 3 times negative 1, which is a negative 3. 3 times 0 is 0. 1 times 3 is 3, and 2 times 3 is 6. So my coordinates are negative 2, negative 6, negative 1, negative 3, 0, 0, that's that origin, 1, 3, and 2, 6. So I'm going to start out up here, negative 2. Oh, now here if you notice 1, 2, and then we're at here at 4. So this grid here counts by 2's. Okay. So actually negative 2 is that first one, and then I go down 6, so 2, 4, 6. So here would be our negative 6. Negative 1 would have to be halfway, and negative 3 would have to be halfway in between the 2 and the 4. Then I'm 0, 0, which is origin. 1 would be in the middle here, and up 3 is going to be in the middle. And then over 2 and up 6. And if I carefully can draw those in, again, they connect, make a line, so that's a linear function. I want you to pause the video, take a couple minutes, and finish this last function table. Remember, this is our x, this is our y, or what's called our f of x, our output. Plug in those values that were given to you at the top in the directions and find y. Graph them on the coordinate plane here and connect your dots. Once you're done, you've finished your lesson on graphing functions.